Okay, guys. So we have here is a company has a spherical storage tank. Okay, so you guys be quick with the maths tables, quick with the calculator. Okay, we get through this pretty quickly. Okay, uh, spherical storage tank. The diameter of the tank is 12 meters. This means the radius is 6 6 meters. Okay, part 1 already done. Okay, volume of the tank. What formula should I use? Volume of a sphere, which is 4 over 3 pi r cubed, which is going to be 4 over 3. Does it give me a value of pi? No, it doesn't. Keep it in terms of pi. So, correct the nearest meter. So it wants it in decimals. And we're going to use 6 cubed. What you get there? And press the change button. 0.779. 905 meters cubed. Any questions thus far? Okay. Volume of sphere. Company paints the outside curved surface of the spherical tank. So you're talking about a sphere, and you want to paint the outside of it. Any idea what formula you should use? Area formula. Found on page 7 or 8, isn't it? And we go again, and we get 4 times pi times 6 squared. Put it in. Yeah, correct the 1 decimal place. 4 meters squared. Okay. Moving on to the next one. See, the first 2 questions are very easy. Okay. So, first 2 questions, very easy stuff. Okay. Then moving on after that, it's going to ask us something a bit more difficult. The curved surface area is painted with a special paint. 1 litre of the paint will cover 3.5 meters squared. How many litres of paint are used correct to the nearest litre? Well, what we said is litres required, or paint required, is going to equal area, total area divided by 3.5. Our area, if I remember correctly, was 452.4. And we're going to divide that by 3.5. And what are we going to get there? 129.2. To the nearest litre, 129 litres. Okay. Some people may be forgiven for rounding that off to 130. I checked the magazine. 130 will also get you the same answer. People's logic is that, look, 129 is not enough. There'll be a small smidgen of area that wasn't able to paint. So they would say, look, round it up to 130 because that's enough to get everything done. Okay, so people got full marks for that argument. Okay. The paint is sold at 25 litre cans. Each tin costs 180 quid. Find the total cost of the paint. So, number of cans required, how do we do that? Anybody cans required? 129.2 litres divided by 25, isn't it? And that ends up to be around 5.17 litres. But you got to round that up to. Can you ask for 5.5 tins? So you have to ask for 6 cans. And how much is each can? 6 multiplied by 180, and you'll get €1,080. Everybody happy with that? Okay. Next one, something that we've seen recently enough, isn't it? Seen something like this recently enough. At another site, the company has a different shaped tank with the same volume. The tank has 2 hemispherical ends and a cylindrical midsection of length h. As shown, the radius of each hemispherical end is 4.5. Find the volume of one hemispherical end. I can't find that in the notes, so what do I need to use? I'm going to use the volume of a sphere, and what I'm going to do then is going to half that. Now, you'd be well entitled to just half the 4 over 3 and turn that into 2 over 3. or you could get the answer and half it at the end, whichever method you want. So what we're going to ask for there, guys, 2 over 3 pi multiplied by 4.5 cubed, and what you get? Yeah, go for it. Yeah, 0.85. Yeah, nearest meter. Okay. The length of the cylindrical section complete to 1 decimal place. It's got to give me some information somehow. Same volume. Keyword there. Same volume as what? Same volume as what? Nope, doesn't say that. Another site, the company has a different shaped tank with the same volume. It must be the same volume as the old tank. So the old tank is on the last page, and there we are there. Our 905, isn't it? So that's your information, your 905, okay? So our old spherical tank is equal to the volume of the new tank. Now the new tank has a system, okay? The volume of the new tank it's made up of a new equals old. Old is 905, yeah. What's the new tank made up of? What different shapes is it made up of? I'd see 2 hemispheres which can combine to make a sphere, and I see a cylinder. Okay, so what I'm going to do is I'm just going to write down. I'll write it down like this: phi hemi velocity of another hemisphere plus volume of a cylinder, not velocity, volume of cylinder equals this. Then what I do after that is I would write down what we already know what the volume of the hemisphere being 191, don't we? So 191 plus 191 plus pi r squared h equals 905. Bring the 191 and 191 over to your side and take them away from 905. So you're going to be doing something like that. Okay? When you do it. So what happens when you do that? 905 minus 191 minus another 191. 523. Okay. Now, pi is pi. What's r squared? .5. And the h value? What we're trying to find out, yeah? Now, let's put this into a big let's put this into the calculator. I'm just gonna highlight part of it. I'm gonna put all that into the calculator. Pi times 4.5 squared, 63.66, 617, yeah. Times h equals 523. Get h on its own. 523 divided by 63.617, and what you get? 8.2? Yeah. Okay guys, this is the 2014 paper 1. So just after going from the 2005 paper 2 onto the 2014 paper 1, shows you that this section actually appears in both exams, okay? And what we're on is question 8b, is that correct, Sam? 8b? 8a, is it? Okay, 8a. The length of a side of a square sheet of cardboard is 12 centimeters. Find the area of the sheet. Well, it says it's a square, which means 12 by 12. Area equals length by width, which is 12 by 12, which is 144. Okay? Centimeters squared. Riveting stuff. Now, the diagram below shows a square sheet of cardboard of side of length 12 centimeters. from which 4 small squares, each of length h, have been removed. The sheet can be folded to form an open rectangular box of height h. Rectangular box. Now it's definitely going to be a like a perfect square type rectangle, like something like that, and something like this here, and then we'll just join them up together. So look, it's an open rectangular box, okay? And what we're saying is that the height, the top of it is open compared to the bottom, okay? So it has 5 faces, not 6 faces. Now, the thing is, what is it from here to here then? This used to be a length of 12. What is its length now? 12 minus 2h. And what's its length from here to here? Remember, it's h getting taken away both sides again. 12 minus 2h. Square sheet, so it's like the one we had here, 12 minus 2h. So what we have here is 12 minus 2h, length, a width of 12 minus 2h, and finally a height of, I'm going to h. Okay? What's the length of the box? Well, let's go for 12 minus 2h. What's the width of the box? Give me a 12 minus 2h. Yep. Okay. 12 minus 2h, 12 minus 2h, yeah? Next page onwards. Show that the volume of the box equals this amount here. Okay? Volume of a rectangular box is length by width by height. So what they want me to multiply is 12 minus 2h by 12 minus 2h by h. Please remember from home is that when you have 3 numbers, you want to multiply the 3 numbers by each other. So example, if I have 3 multiplied by 2 multiplied by 5, you choose any 2 of them to multiply together first, then the answer gets multiplied by the last number. Doesn't matter what order you do it in, it'll always turn out to be 30 for this particular example. Just because it has letters and numbers and stuff like that makes no difference. We'll multiply this one by this one first, and then what's left we'll multiply by h. So we're going to get 144 minus 24h minus another 24h plus 4h squared, and all that will be multiplied by h when we're done. The 2 parts in the middle don't cancel, but multiply it out. (144h), yeah, minus, yeah, take that, won't we? That's what we're asked to prove. So we're done there. Okay. Here's an interesting one. Volume. Maximum volume. Maximum. Where have you heard that before? Maximum, minimum. Calculus. Differentiation. Okay. So I'm going to give you a brief description of what this does. If you want to know what this does, okay, is if I put this into my calculator and I let phi represented by f of x, and then I put in 144, I'm going to let x represent the height of the box, okay? Oh yeah, I'll get that now. Thank you. Okay. Now, should I start off at a minus number? Why not? Height can never be minus, so start off at 0. It has no height, it has no volume, right? If it has no height, it's flat, no height, so there's none to fill. And let's start off, I don't know, something like, we have no idea what ballpark we're talking around here. Let's go up to maybe 50, up in grades of 5. Let's see what's happening. Okay, you can refine it later on. Now look what happens here. X is the height. That gives you what volume you get. It gives you the volume of the box as you go along. Now look what happens. Ooh, it's getting bigger, isn't it? Bigger, 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 bigger again, bigger again, bigger again. Okay, obviously 50 wasn't enough, right? So let's go up in tens from starting off at 50. Let's go up in end of, I don't know, 200. Up in steps of 10. Let's keep going. Oh dear, it's getting much bigger. These numbers are very big. Still going up. 10 to the power 6, 10 to the power 7. Still going up. Up and up and up. Still say maximum, doesn't it? This is interesting, because it says the maximum is when it's 6. So 2 and 6. Ah, there's a problem, right? Here's the problem. Our height can't go above 6. Why can't the height not go above 6? Think about it. Length is 12 minus 2h. If h goes above 6, the length doesn't exist. Therefore, it can't make a box, can it? So our function only works between 0 to 6. I have to copy that now. I knew there was a problem. It just kept going up and up and up. So we go back to where we were. Do this again. Start at 0, end at 6, go up in 1. Ah, here we go. This is a bit more like it. Up. Look there. Bit of a peak at 2, don't we? And then peak at 2. So we're expecting h equals 2 to be our answer, aren't we? So we've made a prediction using the calculator. Now it's just a matter of getting that answer out. So what we're going to do is, in a graph, your maximum occurs when your slope equals 0. Basically, when your first derivative equals 0. We're going to do the VDH. Why is it the VDH? V in terms of h. The VDH equals 0. And what do we get? 144, 96h, and 12h squared. 12h squared minus 96h plus 144 equals 0. Do you know anything about those numbers? All be divided by 12. H squared minus 8h plus 12 equals 0. After that, h minus 6, h plus 2 equals 0. And oh, sorry, that's it. They're both minuses, aren't they? H equals 2 and h equals 6. Why can't h equal 6? Width is 12 minus 2h, and if h is 6, the width is 0. It's not even a rectangular box. One answer, h equals 2. And that's a wrap on that one. What we next want to do is we want to find out what is the maximum volume of the box. The maximum volume of the box occurs when h equals 2. We know that the answer should be 128. But let's figure out how to actually get that 128. Remember, the volume is length by width by height. The length and the width both equal 12 minus 2h, which is 12 minus 2 times 2. Means the length and the width are both going to be equal to, the length and the width are both going to be equal to 8. So when you do length by width by height, okay, we're going to have 8 by 8 by 2. 64 multiplied by 2, 128. So your length by your width by your height. 8 by 8 by 2 equals 128. Cool with that? Centimeters cubed, yeah? Or meters cubed, centimeters cubed.